So I'd like to welcome Simon Smit, DevOps with Firelay. He's going to give us a talk, Simon, in Dockerland about Firelay's experience working with Docker.
Yeah. As I said, I'm Simon, and I'm going to present Simon in Dockerland. I'm a DevOps at Firelay. I came in as a Java developer some years back and slowly became a DevOps. So I'm doing development and I'm also doing operations. Firelay is I think still the only European hosting partner for Liferay. So we're doing hosting, we're doing in the cloud, we're doing on-premise, and we've been moving to Docker now. First I'll explain the goal of our presentation, then I'll go through some hosting history, I'll explain a bit about Docker, I'll go through the development process without using Docker and a development process when you are using Docker. I'll talk a bit about making containers and images for Liferay and about moving to production after you've developed. So the goal. We're a hosting company and we also manage all the Liferays we host, and we want manageable environments, but they must also be flexible to meet demands from developers mostly. As developers usually want to have their changes go through the whole test, acceptance, production phase quickly. But if you're in operations, you want to maintain a stable Liferay in this case. And we'll try to find a nice balance in that and see if Docker can help us with that. So some history in hosting. I'm going to ask a question. Who here knows about bare metal servers? That's very little. Virtual machines or virtual private servers? Still very little. Docker? A little more. That's unexpected. I expected the reverse. But hosting started with just bare metal, actual servers somewhere in a data center or in an office, and they run an operating system with Liferay on it. Every time you get a new environment, you buy new hardware and you install it, and you have to go through all that process. When you deploy something to Liferay, you either do it manually, which is very flexible, or you go through some orchestration software to make sure that everything is stable and manageable, but it's less flexible. Then after the bare metal came virtual private servers. These are still running on the physical machines, but each machine is scaled up and runs multiple virtual private servers. So you have either buy hardware one time and then have lots of virtual private servers on there, or you have a provider for that in the data center. And whenever you have a new environment, you just make a new virtual private server. You don't have to change any hardware. You only have to specify how much resources you want, and you make it and go through the whole setup of Liferay after that. Deployments are still the same, manual or managed. And then we'll go into Docker. As now we've gone past the virtual private servers, we're going to, or we're doing Docker right now. So what is Docker? Docker goes a step further than virtual private servers. The idea is you run containers, and each container runs generally only one process So you can have a container for Liferay, and you can link that up to a container for your database, and a container for Elasticsearch, and so on. And this means that security-wise, everything is separated, and if one component fails, it shouldn't affect the other components too much, as they're completely separate. And well, if your database is going to fail and you have only one database, then obviously it's going to affect Liferay. But if your database is taking lots of resources but still works, then Liferay will be fine. So what you do, you build an image which specifies what you want to run in your container, and you run that container with certain environment variables, which, for instance, say a URL, so you can have the same container for an acceptance environment and a production environment. You give an environment variable for the URL, and that makes sure that it's the same, but on a different URL, and it works, other than that, it works exactly the same. I think that's pretty much what I will tell about Docker now. So the development process we have now without using Docker. Generally, you're going to use an IDE, and Liferay IDE or the Liferay Developer Studio is an obvious choice for that. Both are an Eclipse with a set of plugins in it, and the Developer Studio comes with Eclipse bundled in it, and some EE plugins extra, basically. And then you go, you will use Maven or Gradle, or if you're using 6.1 or 6.2, I hope no one's using older Liferays, you're going to possibly use an SDK. And you will run Liferay somewhere on your laptop, or you have a test environment somewhere. So you'll have a Liferay bundle somewhere on your laptop which you can spin up and deploy to, or you'll do a remote connection with, for instance, the remote IDE connector. But what always happens with me is I get lots of Liferays in lots of folders, and after a month I don't know what was in there anymore, and you get mess like this, and this is only one folder, and I have no clue what is in the Liferays. I have no clue what kind of database they use. If they use my MySQL I had locally, or maybe I threw the database away even. I have no clue anymore. So for me, it makes quite a mess. And with Docker, I hope that will not be the case anymore. So we're going on to developing with Docker. What you need. You will obviously need Docker somewhere. This can be on your laptop. If you have a fairly good laptop, you can run Liferay on there easily in Docker. If you have don't have enough resources on your laptop, you can run Docker remotely. You can have either on a server somewhere, or even on a laptop of a colleague if you really want to go there. And you're still going to use the Liferay IDE or the Dev Studio. For using the Liferay IDE, there is a plugin for Docker. It's called Docker Tooling. It's in the Eclipse marketplace. You click install, and it works. Unless you're using Dev Studio, then it won't work directly. And I think this is because Dev Studio has a slightly older version of Eclipse in it, and you can work around it. And I've asked Liferay for a workaround, and they have provided a workaround. And after you change a bit, then you can get it to work in Dev Studio just fine. So we have the Docker tooling, then we're going to spin up containers, and we want to connect to those. So if you have remote Docker, you want somehow to have a mount folder somewhere where you can deploy in, and you can either do it with a mount or, again, with a remote IDE connector, unless you're using Liferay 7, that is, as the IDE connector will not be made available for Liferay 7. So, for a local environment, and if this works for your remote environment, that's also fine. When you spin up a new container, you can assign a mount folder somewhere, which you can later link up in your project to deploy to. And we're also getting a look at the environment variables. For instance, database credentials with a very bad password. And that kind of thing you can find in the environment variables. So we're going on to the actual development. So with the SDK, you have a build properties file, which lists all the properties you use for building. And there is an auto-deploy directory in there. And if you point that to your mount point, then Eclipse will deploy there, and you can use every feature of Liferay IDE just as you would normally, and it will deploy to your Docker container. For Maven, it's pretty much the same. You have in your POM file, you have a property which you point to the deploy folder. For Liferay 7, it's the same. But you will have to take into account that you need an OSGI/modules folder in your mount, and you shouldn't point it directly to that folder or to the deploy folder, as it will specifically look for that folder. And as last, we have Gradle, which is introduced with Liferay 7. I think a lot of people are looking into that now. You also have a properties in the Gradle properties file for your user. My personal preference would be using Maven, as this one is a properties file that is specifically for the user on your computer, your laptop or desktop. So if anyone else is also working on this project, they need to have the same properties set up, or it won't work like it works on your computer. And with the Maven setup, everything is in the POM file that is contained in your plugin project. And whenever you commit that and someone else pulls that commit, then he will have the same settings and it will all work. And for the SDK, it's the same as Gradle. The settings are for the entire SDK, and if you have a lot of projects in there, you might not want to share all of them with your colleagues. And if you only commit one project from there, you might not get the build properties file shared as well, which will, again, cause issues. One last way you can do it is by cheating and doing symlinks on your actual operating system. This is also still not something that's portable to another developer, and I would not recommend doing anything like this. So here we have the Docker view. On the right, you see a list of images that are available on my laptop. It is connected to the local Docker socket here, which it tries to find automatically. If I want to add a remote connection, I can add a new connection there, and it will show me the containers and the images that are available there. And I can pull images out of the Docker Hub. The Docker Hub is a central storage space for Docker images, which are free to use for everyone. I think, yeah. And you can also connect to your personal Docker repository. And now I will be doing a little demo. So here I have Eclipse, the same view you've seen just now. So I have lots of images, I have an Ubuntu, I have some MySQL things there, and I have Java and lots of Liferay. And I can pick any of these. Let's go for that, I think. I can run it, and it will give me a new container, and I've run this before, so everything I've set up for the container I used earlier, it's going to take the same environment variables, the same container path, so I don't have to set up everything again. I can just edit what I want to edit. For instance, if I want to have 2 Liverays run with a different mount, then I can just change the path there. Or I can connect to a different database. I can even link it up to another container. And there they are. So that you can do kind of what Docker Compose does. Docker Compose allows you to connect different containers together. So you might have, instead of an IP address, just say /MySQL, and that will point to your database container. And here you can do the same. You can add another container you already have, and it will link to that. And if you have set up your image properly, then it should connect to that without using the environment variables. I'm not going to create a new one. I can just spit up. That's one. So I can start one, and it will immediately show me the Liferay log. Liferay is going to start up. It's not going to go much faster in starting up as it would normally, unfortunately. So that might take some time. But I can do a lot of things with these containers. I can, start, stop, etc. I can copy files from the container. I can copy files to the container. And I can execute shell, sort of. So I can run here any commands that my container would support. Whatever I would like. It doesn't really help you very much, as there's no tab completion or even backspace doesn't work. So every time I type something wrong, I have to go to a new command, which is quite annoying. But then again, the idea with Docker is you don't execute a lot of commands on your container, because everything you do manually on a container might be lost again when you spin that container up with a new image. So if you were used to doing a lot of things manually, you should now build that into your container in either a startup script or something else there. And I think my Liferay is still not booted, so I'm thinking. Oh dear. Yeah. So I think we'll go back to presentation then. It's deploying things. But rest assured, at the end, there will be a Liferay. And I can kill any one of these containers there. Yeah. There we go. So we've been doing some development with Docker, and now we'll talk about making actual images for your Liferay. I didn't show you that there, but in an earlier slide there was an image of the Docker Hub link, and I searched for Liferay there, and there were, I think, 25 different images. So there is a lot of choice you have there, and before you pick your image, you should really consider, what do I need for this environment? Do you need a certain database? Do you need an Elasticsearch or a Solar with it? Maybe you want to build your own image because you want to do something special. These are all options you have. And there are lots and lots of choices. What you can also do is base your image on another image that's already available. Docker, as images are working with dependencies, usually you start your image with a dependency on another image. So for instance, usually at the bottom somewhere there's an image for an operating system, and on top of that will be an image for, say, Java. And then on that Java image, you're going to build your Liferay image, which will make use of Java and of the operating system under that. And what you can do is take one of the Docker images from the Docker Hub and build your own image on top of that for your own special needs. So you have your image, and now you want to go to production. What we have done here until now is do hot deploys into Docker containers directly, and that works very well for developers. They can easily deploy for a test environment. For instance, you can hot deploy and share it with your colleagues instantly, but you can also break things instantly, and that's definitely not what you want on an acceptance or a production environment. So for an acceptance environment, what you can do is you do the deployment to test first, then you pull out.
Sorry, just a question.
The question?
Yeah. So when you're deploying, so you're using this to deploy to production. Now, how often would you always rebuild and start again from a fresh container, or will you sometimes just do code deployments? So starting with the Liferay server might take a little bit of time. And one of the benefits of Liferay, of course, is you've got the zero downtime deployment. So if I'm just changing, one of my applications and deploying that, I can deploy that and it picks it up straight away without having to turn the server off.
I will come to that. Okay, so we were at acceptance. So you do a deployment to the test environment. Then when you're happy with that, you can pull out the deployed plugin from the OCI folder, or the Tomcat Web Apps folder, for instance, and you make a new image based on your standard Liferay image, and you add on top of that a layer that says, okay, add this file into this image as well. What you get then is an image for acceptance, and when you test it on acceptance and you say, okay, this is good, you can switch the image on your production container, and you ensure that your acceptance environment and your production environment are exactly the same. So any testing you did on the acceptance environment is also valid for your production environment. You can even go a step further and clone your production environment first, so you have all the data in there, and you can test with that on the new image. And coming to the question, indeed you have to spin up a container again when you change the image. But what you can do is clone and spin up a new container with the new image while the other one is still running. And when your Liferay has started up, you can switch them over. So it will be a seamless transition instead of having some downtime for every deploy. And I think for Liferay there are flexible licenses that allow you to do that as well without any extra costs. And one of the benefits for this is whenever you got through your whole testing but still found something you really don't want, you can roll back by going back one image and spinning up a container with that again. Or even if you did clone the container beforehand, take the old container and throw out the new container. And as I said, spin up in parallel, you can spin up the new container next to the other ones. Also a good thing, this is quite easily integratable into any build pipelines you may have. For your development process, you can have the test server and take your, say, Jenkins or so, and make that deploy to the test server and run some tests. And if they all complete, build a Docker image from that test environment and deploy that to acceptance for either more automatic testing or manual testing. And we're going to production on the Firelay platform. We have the both the hot deploy features and the images. We provide a separate image repository for customer images, and they can base them on our current Liferay image, so that everything works in our environment, but you can still base your image on that. And we have added an extra feature, which is Elk, which is Elasticsearch, Logstash, and Kibana. The Elasticsearch and Logstash allow you to gather up lots of logs from lots of different places, and Kibana will visualize that, and this allows you to search through logs, for instance, from your Elasticsearch or a Solr you might have, or a database, and from your Liferay, and you can match these. For instance, if you have something happening on your database at the same time as something is happening on your Liferay, you will see those happening at the same time, and you can easily see, okay, this is caused by this, and you can do a lot of debugging with that. So, quick recap. We've been doing developing, so spinning up containers and not making a lot of mess everywhere like I do, and always having access to a clean Liferay, because you just have to spin up a new container with the same image you used before. And we can ensure that the acceptance and production environment are the same as much as possible, and only the environment variables have to vary for that. And with that, we come to the goal of the presentation, having flexible but also manageable environments. And so for developers, you can be flexible with hot deploys, but you can also be manageable with the Docker images. And I think that is the presentation.